All right. Well, we're gonna give her a quick test. Um, all right, class. First time I've ever done this, so bear with me. We are in chapter 14, acids and bases, and so I'm just gonna kind of run you through this. It's gonna be quick. Um, you need to pause it to take notes, probably. I've got some practice problems we can pause. So let's do this thing that we call school. Acids and bases, chapter 14. Here are your learner objectives for the day. We need to be able to describe the properties of acids and bases. We need to name them. And no, we don't get to just call them Jeffrey or George. We actually have to do proper chemical nomenclature. So we'll be naming acids and bases, mostly review for some of you. We need to list some industrial uses of acids. We use acids every day in industry, and so we just need to get familiar with some common ones we might see out and about in our after school lives. Explain the difference between strong and weak acids and bases. If you remember talking about the difference between strong and weak electrolytes and the degree of dissociation, this should be exactly the same. Our compounds are now acids and bases. Objectives. Here we go. Section 1. Properties of an acid and bases. We're going to start with aqueous solutions of acids. Again, aqueous just means they are dissolved in water. Aqueous solutions are going to taste sour, if you can imagine a lemon or something along those lines. They can change the color of acid-base indicators. We'll be familiar with phenolphthalein. If you remember the little rainbow demo thing we did, that was universal indicator. Some acids can react, or most acids react with active metals to release hydrogen gas. And then acids react with bases to produce salts and water. That's going to be our overall kind of a net ionic equation is really going to be the formation of water. But if we look at the entire equation, it's going to be the formation of water and a salt. And then acids conduct electricity. They are electrolytes, not because of dissociation. If you remember the word, it's because of ionization. Common acids. And so again, common acids are going to be things we find all the time. There are acids in fruits, citric acid, all kinds of fun stuff like that. It has sour taste, and again, usually an indicator that it is an acid. Okay, binary acids. Binary acids are going to contain only hydrogen and one more electronegative element, usually group 17 elements primary. And I have this here because our stomach produces a binary acid known as hydrochloric. And so naming binary acids, we always start with the prefix hydro and then the root of the name of the second element. So we're going to take the root and then add ic to it. In the case of HF, we're going to call it hydrofluoric acid. Here, HCl, hydrochloric acid, so on and so forth. Now remember, these are binary, so they're going to be made of hydrogen and one other element, but we can't have multiple. We're just looking at two different elements within a binary acid. Give her a quick practice, pause the video, try real hard. If you don't get them right, then you can ask me questions in class. Hey, or virtually. That's enough time. You can pause. Here are the answers. So we have pretty much standard form. We've talked about this a million times. All right. Oxyacids, they're going to contain hydrogen and oxygen, usually a third element, usually a non-metal. Nomenclature of oxyacids slightly different. We got to determine the name of the polyatomic ion combined with hydrogen. If the name of the ion ends with ate, we replace it with ic. If it ends with ite, we replace it with us. And for example, things like this one down here, we know that this is nitrate. Nitrate ends with an 8. It's an acid. I see that hydrogen combined with it, so I know I'm going to use acid nomenclature. I'm going to take nitrate. I'm going to drop this ending. I'm going to put down ic, and I'm going to put acid at the end, and so I get nitric acid. And then in this case, this is nitrite. I'm going to go ite to us, and it will be nitrous acid. One good way to remember it is I always like to tell people that I ate something icky. Reminds one, but you can't ite something ousy, and that just sounds weird. So, hey, it kind of works. Give her a shot. Again, pause the video because I'm going to go fast. There's the answers. I hope you got them right. If not, please, 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 please get a hold of me and we can have a quick conversation. Oh, man. You knew I was going to screw it up. Well, there's the answers with the next practice problems. I'll be better next time. Sorry, firsties. Okay, give the common industrial acids. We have sulfuric acid. It's going to be used in batteries, metallurgy, petroleum refinery, all kinds of fun stuff like that. Super, super, super commonplace. H2SO4. We've got HNO3. This is nitric. use this to stain proteins, stain skin yellow, manufacture explosives. Yep, yep, yep. Remember, I told you to use your powers for good. None of this, please. Okay, plastics. Plastics. Plastics are useful, and pharmaceuticals, especially currently. Right? Phosphoric acid, H3PO4, primarily used in the manufacture of fertilizers, that kind of fun stuff. Also flavors our beverages. Right? Hydrochloric acid produced by the stomach. You can call it muriatic. That's how you'll find it in Home Depot. And used to clean masonry, maintain acidity of swimming pools, that kind of mumbo jumbo. And then acetic acid. We are familiar with acetic acid. It's a fungicide, but we use it. It's vinegar. Yay! It's produced by the fermentation of certain plants. Also used in manufacture of plastics. Properties of bases. Ooh, we're there, we're there, we're there. Bases are going to taste bitter, right? You know some base-like people, those bitter people. Just kidding. Dilute aqueous solutions of bases, they're going to feel slippery. Think soap. They do also change the color of acid-base indicators, and they will react with acids to produce salts and water. They are also electrolytes. And base nomenclature, most bases contain hydroxide. We'll talk about the different types of bases. Most bases also contain a metallic ion. Number of hydroxide ions is determined by the charge of the metal ion. So a +1, a -1, NaOH, a +2. We're going to need 2 of those. A +3, or we're going to need 3 of those. Okay, naming bases, super difficult. I mean, it's going to be bad, right? No, kidding. We just name the cation and then add hydroxide. So this is barium hydroxide, ammonium hydroxide, and then finally potassium hydroxide, right? Different versions is going to be the hardest part, is remembering the different types and words that go along with acid-base definitions and kind of acid-base theories. So we are working currently with what we call the Arrhenius. An Arrhenius acid is a chemical compound that increases the concentration of hydrogen ions. We're going to call this hydronium eventually. This really doesn't exist in solution. It combines with water to form this species. And so we're going to refer to Arrhenius acids as things that increase the hydronium ion concentration of a solution by the addition of a hydrogen ion. Arrhenius base is a chemical compound, increases the concentration of hydroxide. If I take this and I add it to this, I could get 2 water molecules. We're going to see that eventually, kind of in a balancing. We start looking at the Kw for water, the ionization constant. Acid-base strength. Again, a strong acid, it's going to ionize completely in aqueous solution, 1-to-1. So for 1 mole, I'll get 1 mole of particles. Weak acid, it's not going to be 1-to-1. I'll throw in 1 mole of weak acid and maybe get like 0.005 moles of particles that have now gone up into solution. So again, difference is the amount of dissociation. That's going to be the exact same with a strong base. Strong base like sodium hydroxide, complete dissociation. Weak base, aluminum hydroxide really doesn't even do anything. You throw it in water and aluminum hydroxide, it just sits there. Okay? I hope you can describe some properties of acids and bases, kind of know how they feel, their taste, that they change litmus paper, that kind of fun stuff. We'll practice lots and lots of nomenclature. You know that. We've been doing that all year. Hopefully we can do that. List those industrial acids. Make sure you know those industrial acids. You will see that on the exam for this. And then again, this is all the extent of ionization a species exhibits when put into an aqueous solution. And we can talk that all the time. And finally, I know you've been waiting for it. 1 through 5, page 458. Have that due for me tomorrow. You can text me it. You can email it to me. I'm going to load those into Google Classroom later on this afternoon. And we're going to call it a day, folks. Thank you so much for your attention and your time. Same bat time, same bat channel. I'll be back tomorrow day.